Hello, I am going to discuss some questions of NCRT, chapter electricity, index questions. I think some of the questions, not all the questions. For example, calculate the number of electrons constituting 1 coulomb of charge. Now, like a charge on one electron is 1.6 into 10 to the power minus 19 coulomb this year now. So 1 coulomb is equal to how many electrons? So we have to find here n number of electrons. Here n is equal to q by e it is here now. Okay. So that is equal to now 1 coulomb by 1.6 into 10 to the power minus 19. This is electrons. This much electrons. And after calculation, what you will get? 6 into 5 into 10 to the power 18 electrons. So this is the answer. Okay. So number of electrons is equal to number of electrons in 1 coulomb is equal to this much of electrons. This is the answer. This is the answer. This is. Now the next question. This is question number 3. Now the next question 7 it is. Now on what factors does the resistance of a conductor depends. Okay, on what are the factors on which the resistance of a conductor depend? So there, okay, the answer is now like here. Answer is the factors. The factors are number 1, length. Its length it is now. Its length L it is. L. It's okay. And how does the resistance depends on length? So that depends. R is directly proportional to L. R is directly proportional to L. Means when L is more, R is more. L is less, R is less. Now number 2. Then its cross-sectional area. Its cross-sectional area. So how does it depend? On cross-sectional area with A here now, it depends. R is inversely proportional to 1 by A here. Means when the cross-sectional area is more, R is less. When cross-sectional area is less, R is more. This way it is. And the third factor is resistivity. That is rho. On rho it is here now. And okay, of its material, and so R is directly proportional to the rho it is now. It is directly proportional to the rho, because when rho is more, R is more. When rho is less, R is less. It is. So this is the answers, right? Okay. Now there is one more question. The question is, will current flow more easily through a thick wire or a thin wire of the same material when connected to the same source? Why? The question is that now, will the current flow easily through a thick wire or thin wire? Okay, so the answer to this question is that the resistance of a conductor is indirectly proportional to the cross section area. A thick wire has more cross section area, a thin wire has less cross section area. Okay, therefore the resistance will be less in thick wire, therefore the current will pass easily in thick wire. Right, so this is the answer, because R is this is question, this is not the question. So the question is here now in the book. Thick wire or a thin wire it is. This is question number 2. The question number 2 it is, and the page is 209. This is 209. This is page is 209. Okay, why it is here now? Okay, so the current will flow easily into the thick wire because R is inversely proportional to the A. It is now okay. A thick wire has more cross section area, more cross section area. Okay, a thick wire has more cross section area, therefore R is inversely proportional to A. If A is more, okay, R will be less. Therefore, current will pass easily into thick wire, into thick wire. Is right? Yes. This seems to be a standard, no? Yes, but it is true. So a thick wire will have